Welcome back to our class for our midterm. For week module number 4, our topic is about conductance, susceptance, and admittance. So first, let's tackle about admittance or Y. Reciprocal of impedance. Since kabalo na ta what is impedance, so the old unit is mo. So reciprocal sa tong ohm is mo. The SI unit is called Siemens. So we have our formula here for impedance. Since kabalo na taani from our last topic, we have Z is equal to R plus JX. So therefore, di ba giingong admittance is reciprocal. So Y is equal to 1 over Z. While ang atoang Y is equal to, so pwede po siya G plus or negative, positive or negative, JB. So ang G is the conductance nga given and B the susceptance in Siemens or mho. Mao ni ato ang unit and ato ang symbol. So take note nga ang positive B or susceptance is capacitive. You have here. And for negative B is for inductive. So formula for our conductance, so we have R over R squared plus X squared. And for our susceptance, so we have X over R squared plus X squared. So we have our figure here. So makita nato natay total voltage na current, and we have our impedance nga given and ang ilahang current drop sa every impedance. So solving for total conductance, we have GT or total conductance is equal to G1 plus G2 and G3. So and so on and so forth. So take note that our total conductance is equal to the arithmetic sum of the conductance in each branch. So take note ang atong conductance is arithmetic sum. So for our total susceptance or BT is equal to B1 positive negative B2 positive negative B3. So for our susceptance, so is equal to the vector. So we have here vector sum of the susceptance in each branch. And for our total current, basic, which is IT, total current, is equal to total voltage and divided by sa total impedance. So pwede po ta, therefore, pwede po ta makasolve using our Y. So admittance, if given ang atong admittance and our total voltage, so pwede ta makasolve og total current. So i-multiply lang nato ang duha. So IT is equal to ET multiply to YT. First, sa atong example, i-apply nato. So we have find the total conductance and total susceptance of a 5 ohm resistance in series with a 100 microfarad capacitor connected in parallel with a 2.5 millihenry inductor. Assume W is equal to 2000 rads per second. So first, we need to draw our figure. Since gaingon siya ng ato ang 100 microfarad is connected in parallel with a 2.5 millihenry inductor. So first, let's write our given from our problem. We have our capacitor 100 microfarad and our L, which is 2.5 millihenry. So first, since naamantay capacitor, so we need to solve for our XC. So formula for our XC, since natay given nga W, which is 2,000 rad per second. So substitute from our formula, from our given data, we have 1 over 2,000 multiply sa capacitor nga 100 microfarad. So our XC will be 5 ohms. So after na to ma-solve sa atong XC, we need to solve for our XL. Well, our formula for our XL from our previous topic, we have W multiply sa to ang L. Since given tanan, we have 2,000 multiply by 2.5 millihenry, so negative 3. Our XL will be also 5 ohms. Since giingon sa problem nga connected in parallel, so therefore we need to solve for our impedance. So total impedance, since parallel man siya, so 1 over ZT is equal to 1 over 5 minus J5. So asa man tagikan aning 5, since given man sa tuang 5 ohm resistance. And our XC is 5 ohms sad, so same ra, plus 1 over J5. Since parallel circuit ang gihatag sa problem, so since giingon nga ang admittance is the reciprocal, so first we need to solve for our total impedance. Since complex, so we need to convert our calcu into complex. So 1 over 5 minus 5i plus 1 over J5 or 5i. So our answer will be 0.1 minus 0.1i or J 0.1. So we have our answer here. So therefore, diba giingon dito sa taas nga ang ato ang GT. So admittance is also equal. So balik ta. So admittance is also equal to J. Admittance is also equal to J plus minus JB. So from our answer ganina nga solve sa atong admittance, therefore we conclude nga ato ang GT is equal to 0.1 ohm or no 0.1 rather mho, and our BT is 0.1 mho, which is inductive. Since negative man siya, so our BT or susceptance is negative or inductive. So proceed ta for our second example. So we have here a two-branch parallel circuit has Z1 is equal to 2 plus J4 ohms and Z2 is equal to R. Solve for R to result in the overall power factor to 0.9 lagging. So sa itong problem, nag-ingon siya parallel circuit. So natay given nga Z1 which is 2 plus J4 ohm and our Z2 is R or our unknown. So first draw ta sa itong figure na ay given nga total voltage, ang ato ang impedance 1 and impedance 2. Since giingon parallel circuit, so we have here parallel sa tuang duha ka impedance. So for formula for our parallel total impedance, so we have 1 over CT is equal to 1 over Z1 plus 1 over Z2. So substitute. So So 1 over zt is equal to 1 over 2 plus j4 plus 1 over r, ang ato ang unknown. So 1 over 2 plus j4. So first we need to solve that. 1 over 2 plus 4i. So our answer will be 0.1 minus 0.2i or j 0.2 plus ang atoang ikaduhang impedance nga 1 over 4. So substitute nato para ma-solve nato ang r. Therefore 0.1 plus 1 over r minus j 0.2. So first we need to solve our r. Since naghatag siyag power factor from our problem, which is 0.9, so gamitan na to og auto ang power triangle. So we have our GT, BT, and YT. Since naghatag siyag 0.9, so our angle here, so we need na to i-solve. So first, we need to convert our 0.9 power factor into power factor angle. So cosine. So we have 0.9. So we have shift. Convert muna natin. So since complex to ganina, shift cosine of 0.9. Since angle atong gipangita, our angle will be 25.84 degrees. Since, di ba, giingon ang GT dito sa taas, kani dere, Y ang atong admittance equal to G plus minus JB. So given natay tangent, since natay given nga G and natay given nga B, which is 0.2. So tangent, since so katowa opposite, so opposite niya is 0.2 kaning J 0.2. So we have 0.2 towa hypotenuse ang ato ang y. So we have adjacent niya, since so katowa, so adjacent, tangent opposite over adjacent. Atong adjacent is J, G. So we have here 0.1 plus 1 over r. So solving for r, pwede na nato ma-solve atong r. We can also use the shift solve technique. So we have tangent of 25.84 alpha solve 0.2 divided by 1, 0.1 plus 1 over tong unknown nga resistance. So shift solve for x if x is 0. So our r will be 3.195 ohms. So this is our final answer. Sinasabtan ra. So next, for our next topic, so proceed na ta for AC 3-phase circuits. So phase voltage induced in each coils of a polyphase AC generator. So sa 3-phase na to, so we have our coil A, our coil B, and coil C. So kani siya, kani nga figure, mao ni ang ato ang 3-phase alternator. Since 3-phase, so naay tolo gadagan, which is an angle nila difference is 120 degrees. So EA is the voltage induced in coil A, or atong EA pwede nato siya matawag nga phase voltage in coil A, coil B, and coil C. So in a balanced three-phase voltages, the magnitudes of the phase voltages are equal and out of phase by 120 degrees. So kani sa tong figure ganina, mao niyang ato ang balanced three-phase voltages. So phase sequence or phase order, the order of rotation of the coil voltage in a balanced fully phase system. So ang sa atuang balanced fully phase system naatay phase sequence or phase order. So makita na to dire. For our positive sequence, we have A, B, and C. And for the negative, A, C, and B. So take note ta, so nanasilay angle which is total of 360 degrees. So take note, to change the phase sequence from ABC to ACB, the direction of rotation of the coil voltage in the alternator must be reversed. So dapat og ma-change ta sa atong sequence. So ang atuang rotation or direction is reverse. Take note also that positive phase sequence are sometimes named 1, 2, 3 or RYB sequence. So sa atuang AC three-phase circuit, we have a balanced star or Y connected system. In this setup, similar ends of the three phases are joined together to form a common junction N called the neutral point. So sa ato ang balanced star di ay na siya common junction or our neutral point. So relation between the phase and line voltages, since three-phase man ta, so EL is equal to square root of 3 EP. So ang EL nato is line to line voltage. And our EP is the phase voltage. So relation between phase and line current, so IL is equal to IP. So therefore, ang ato ang line current is equal sa phase current. So for our phase voltages, sinhuman na ta sa tong current, so for voltages, EA is equal to EB and equal to EC, or maning gitawag na phase voltage. So in our line voltage also, we have EAB equal sa atong EBC equal to ECA or our line current. So makita nato na take note nga the line voltage leads the corresponding phase voltage. So take note, ang line voltage daw is naka-leading siya sa phase voltage by an angle of 30 degrees. So take note ta ha, sa ato ang three-phase nga ang line voltage is naga-lead siya og angle of 30 degrees. So makita nato dire. So we have katong E kaning, so given nato, so na siya 30 degrees. So gaon na ang EAB. So have here EAB, our EBC, and our ECA. We have here, so kanin tolo ang ato ang line voltages. So opposite ana, so we have here, makita na to, negative BN So, mo na ito ang neutral point. So, yung opposite. So, we have negative. Mo na ilahang neutral point. So, using double subscript notation, so, gamit sa makita na to na figure, so, galid ni siya 30 degrees sa every corresponding phase voltage. So, we have EAB. So, for our EAB here, so, is equal to kaning AAN plus or minus sa atuang EBN. So, makita na to dire, kanina angle. Kani dire. So, atong sa AAB na to, naman tayo neutral, plus siya sa negative, ang opposite sa BN. So, we have here, and for our EBC, so same ra gihapon, EBN plus negative sa CN. And for ECA, we have ECN plus negative EAN. So, i-apply na to for our example sa balance star or Y. So, nga, Y connected. So, makita na to sa tong figure ha. Maka-form siya og Y. So, for our example, a balanced three-phase Y connected source has using positive phase sequence. Na given nga EAN is 390 with an angle of 30 degrees volts. Determine EAC. So, kabalo na ta sa ato ang positive sequence sa taas. Sa gali to. So, recall ta for our positive sequence. So, we have A, B, C sequence. So, makita na to, i-draw na to sa ato ang EAN. Since naghatag siya 390 with an angle of 30 degrees. So, therefore, from our 0 angle, so, na siya 30 degrees. So, mao ni ato ang AN with 390 volts. So, ang gipangita na to ay EAC. So, therefore, diba sa atong formula is ECA is equal to ECN plus negative AAN. Since ang gihatag is EAN, so natay given nga EAN, so we need to solve for EAC. So, ang reverse aning ECA. So, therefore, kani, baliktad na to. So, una man ang atuang A, therefore, kaning EAN na given, una siya, which is 390 with an angle of 30 degrees. And our ECN, so from 30, since positive, so na siya 150 degrees. So, from 30, so kaning 130 dire, 30 degrees, plus ato ang 120 degrees. So, therefore, 150 degrees. So, we need to solve for our EAC. We use our calculator, so convert in complex. So, we have 390 with an angle of 30 degrees minus 390 with an angle of 150. So our EAC, our answer will be 675.49 or approximately to 675.5 with an angle of 0 degrees volts. So nasabtan ra. So that is our topic for our module number 4. So I hope mag-study in advance for our midterm quiz, hopefully this Friday. So if you have any question, pwede ra mangutana ni ma'am sa ato ang Google Classroom para matubag nako. So that's all for our topic this module 4. So thank you.